Hi guys, hope you're having a wonderful day. Today we are going to learn about types of reactions. This is one of my favorite lessons. So at the end of this lesson, you'll be able to look at different reactants and say, oh, this is this type. And hopefully in the future, very soon, you're going to be able to predict what the products are and write balanced equations for them. So we're going to look at several types of reactions here. The first one is called synthesis. It's also known as combination. So synthesis or combination, or also known as composition. So any of those three mean the same thing. Here we are synthesizing something, so that means we are making it. And so we're going to take parts, put them together to make one big thing. So you're going to see that you have different parts like A plus B, and you're going to form one larger substance as AB. For the purposes of our class, we're only going to look at forming binary compounds, meaning a compound made up of two elements. So you're going to see that you have an element plus an element, and then we're going to yield a compound. So for each of these reactions, we're going to do a demo, an example, and we've done, I think, all of these reactions already before, but now we get to write our equations and explain what's happening. So I'm going to go ahead and light a Bunsen burner here. And I'm going to light a piece of magnesium. So here's some magnesium, a small piece. And I'm going to hold it in the Bunsen burner flame. And this is a synthesis reaction. So we started out with some metallic magnesium. Here's what metallic magnesium looks like. And we reacted it with oxygen. The oxygen came from the air. Oxygen is diatomic, so it's O2. And then our product is this white powder. I don't know if you can see it very well. So what do you think this powder is? Well, we formed a compound that combined magnesium and oxygen, and so that's magnesium oxide. So to write magnesium oxide, since this is ionic, we need to check our charges. So magnesium ion is Mg2 plus, oxide ion is O2 minus, so our product is MgO. And then let's balance our equation. To balance our equation, we need to use coefficients. And so I'm going to put 2 here, so I balance my oxygens, and then 2 here, so I balance my magnesium. So I want you, at the end of this lesson, to be able to look at just the reactants portion and to be able to tell what type of reaction it is. That's all I want for the purposes of this lesson. In the next coming days, we're going to practice each type a little bit more and try to predict products for it. So for now, all I want you to be able to do is recognize if you see two elements added together as your reactants, that is going to be a synthesis reaction, and your product is going to be a compound. Let's move on to decomposition. So decomposition is the opposite of composition or combination or synthesis. This is when you're breaking down things. So decompose means to break down. So in decomposition, you'll see that you have one large substance, say AB, and it's going to break down into 2 or more smaller substances. So breaking down as opposed to making. So for the purposes of our class, we are going to look at a compound, and it's going to break down into 2 elements. So it is the exact opposite of synthesis. But just know that anytime that you have a larger compound, even if you break it down into smaller compounds, that is still decomposition. So anytime you're breaking down, that would be decomposition. So my demo for this one is I have some hydrogen peroxide. And hydrogen peroxide decomposes on its own. But to speed it up, we're going to add a catalyst. So here's hydrogen peroxide, looks just like water. And I'm going to go ahead and add a catalyst for that. I'm going to light a Bunsen burner because I'm going to need it in a minute. Okay, so here is my hydrogen peroxide. My catalyst that I'm using is something called manganese dioxide. And I'm going to take just a tiny bit of that. And I'm going to add it here. Now if you can hear it, but hopefully you can see the bubbling and the gas forming. Now to check what gas is forming, I'm going to light a wooden splint here. And I'm going to blow it out, put it back in here, and it reignites. Isn't this cool? Could do this for hours. So my hydrogen peroxide is H2O2. So let's write that down. That's my compound. I added a catalyst. My catalyst was manganese dioxide. You don't need to know that. Just remember that you put the catalyst on top of the arrow. And my products, well, I formed a gas, and I checked what that gas was. What kind of gas, helps something reignite? Well, that would be oxygen, right? So oxygen is one of my products. My other product is water. Now, this is just an example for us in class, but the problems that you will have to figure out will always be you break up your compound into its elements. This one's breaking up into an element and a smaller compound, but it's still considered decomposition. Let's balance it. So you would need a 2 here and a 2 there. Let's try NaCl, for example, just as an example in your notes. So that would break down into sodium and chlorine, so Na and Cl2, because chlorine is diatomic. So how do you recognize that you have a decomposition reaction? Well, your reactant is going to be just one compound. That's all. So the only thing that that compound can do is break down. So decomposition is the exact opposite of synthesis. Let's look at the next type. The next type is combustion, probably everybody's favorite. And we're only going to look at combustion of hydrocarbons this year. Combustion of hydrocarbons. Combustion means rapid addition of oxygen. So our hydrocarbon means that you have a compound that's made up of carbons and hydrogens, or carbons, hydrogens, and oxygens. So we're going to say CXHY as our hydrocarbon. We're going to add oxygen to it. So we're going to add O2. And when you rapidly add oxygen to the carbon, you're going to form carbon dioxide. When you add oxygen to the hydrogen, you're going to get water. And so for combustion reactions, they are the easiest to predict what the products are because they're always going to be CO2 and H2O, but they are the trickiest to balance. So let me grab some alcohol so we can burn it. Sorry about that. So I got my alcohol, my methanol, in my water jug. We've seen this before. I'm going to empty out all the extras, and then I'm going to light it. Get the camera on it. Ooh, that was a loud one. So we've got our methanol in here. Let's write the formula for methanol. Methanol is CH3OH. We have oxygen in the air that reacted with it. And we are going to get CO2 and H2O. Let's see if we can see some of the water that we formed. I don't know if you can see that in there. There's the liquid water. And it is filled with CO2 right now. So if I try to relight it, it's not going to really do anything because there's no oxygen inside. It's all filled with CO2 gas and some water vapor. So let's try to balance this. So we would need 1 carbon, that's good. 4 hydrogens on this side, so we're going to make that a 2. And then for the oxygens, I have right here 2 and 2, that's 4. So 2 and 1, that's 3. So that doesn't work. We have an even number and an odd number. So I'm going to double this right here. And I'm going to double my water as well. So make that a 4 so that I have 8 hydrogens on both sides. Then now for my oxygen, and I need to double my carbon as well. So 2 carbons right now, 8 hydrogens on both sides. And then for the oxygens, I have 4 and 4, that's 8. I have 2 here, so I need 6 more, so I'm going to make this a 3. So again, combustion reactions are the kind of the trickiest to balance, but they are the easiest to find products for. So how do you know that you have a combustion reaction? Remember, just by looking at your reactants, you will see a hydrocarbon, so a compound that's made up of carbons and hydrogens, or carbons, hydrogens, and oxygens, and then plus O2. And that's how you know that it's a combustion reaction. Let's move on to number 4, which is single replacement. So single replacement is where you have an element and a compound. Element and compound. And when this reacts, you will get a different element and a different compound at the end. So, for example, in this case, you might get AC plus B or AB plus C, depending on what type it is. So, for the demo for this one, I'm going to take some copper. So, copper is Cu. And I'm going to add some silver nitrate. So, silver nitrate is ionic. It is Ag plus and NO3 minus. So AgNO3. Now this is a solid, but I have it dissolved in water. So I'm going to put my copper in a test tube right here. And I'm going to add my silver nitrate. And hopefully you can see that there is a color change happening. Looks like, you know, there's something forming that is kind of grayish or silverish on the copper here. So let's see what's happening. So what's going to happen here is this element is going to come in and kick out one of the elements that's in the compound. If it's a metal, it's going to kick out the metal. If it's a non-metal, it's going to kick out the non-metal. So in this case, Silver is my metal, so the copper will go in and kick out the silver, so silver is going to be now by itself, and then the copper will take the place of the silver and make copper nitrate. And it's actually copper 2 nitrate in this case. So let's look back at this right here. The stuff that's building up on the copper is actually silver. I don't know if you can see it a little bit better like this. This is silver that is forming, and then the solution is going to be copper nitrate now. So let's balance it. You would need 2 nitrates and 2 silvers. So how do you recognize that it's a single replacement reaction? If you look at your reactants, you will see that you have an element and a compound. Now, looking back at combustion, you also have an element and a compound. But if it's combustion, that element has to be O2, and that compound has to be a hydrocarbon. If you see an element and a compound that is not a hydrocarbon plus oxygen, then that tells you that it's single replacement. And it's called single replacement because one single thing, one element, replaces another element. It's also known as single displacement as well. Displacement or replacement kind of mean the same thing. Next is double replacement. So 2 things are going to replace other things. And here you will start with 2 compounds, and you will end up with 2 different compounds. So let's say you have A, B plus C, D. What you will form will be AD plus C, B. The 2 outer ones kind of go together, and then the 2 middle ones go together. So for our demo here, I have some potassium iodide. So potassium iodide is a solid, but this is dissolved in water, so it's a solution. And lead nitrate, lead 2 nitrate, also a solid at room temperature, but this is a solution. So they're both clear, colorless solution. I add them together. Remember this demo? And you get something that looks like it's a thick yellow liquid, but it's actually a yellow solid, and it's going to precipitate after a while. So let's write down what's happening here. So potassium iodide, K plus and I minus, so Ki. Lead 2 nitrate, Pb2 plus and NO3 minus, so Pb, NO3, 2. So what happens is the 2 outer ones go together. The potassium and the nitrate go together to form a compound. So K plus and NO3 minus, that's going to form KNO3. We don't care that there's 2 nitrates. Remember that subscripts are used to make neutral compounds. Then we're going to worry about balancing after. Then the 2 middle ones go together, so the iodide and the lead. And remember that the metal goes first, and so the lead goes before the iodide, and that's why here I wrote Cb as opposed to Bc. So Pb2 plus I minus, so your compound is going to be PbI2. And it's actually PbI2, lead to iodide, that is yellow in color and it precipitates. Let's balance it. So we need 2 here and 2 there. So with double replacement, you have 2 things kind of switching partners. And to know that it's a double replacement reaction, you're going to start with 2 compounds. You'll see 2 compounds in your reactants. Last type we're going to talk about is neutralization. Neutralization is actually a special type of double replacement. So because it's double replacement, it is a type of double replacement, you're going to start with 2 compounds. But they are 2 special compounds. One of them is an acid, and the other one is a base. To know that it's an acid, it's going to start with hydrogen. So HA is going to be our example of an acid. There is no A on the periodic table. This is just like the A and the B that we were using before. And for the base, it's going to end with OH. That tells us that it is basic. So it's a hydroxide ion. So your products are going to be water and then BA, water and salt or an ionic compound. So for example, let's say you have HCl and KOH. So we know that HCl is an acid because it starts with an H. We know that KOH is a base because it ends with OH. So this is a double replacement. And so we are going to do it the same way. So the two outer ones go together. Well, you have the two outer ones as H plus and OH minus. So that's going to be HOH, which is water. And then the two middle ones go together. So the Cl minus and the K plus. But remember, K plus will go first. So KCl. And that is already balanced. So how do you know that you have a neutralization reaction? Well, you're going to start with two compounds, just like double replacement, because it is a type of double replacement. But those two compounds are going to be special because one of them will start with H, the other one will end with OH, telling you that one of us is an acid and the other one is a base. So hopefully by now, if you look at a reaction and you look at just the reactants portion, you are able to tell what type of reaction it is. Have a great day, guys.